Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going to be answering question number 8 from the International A-Level Pure Mathematics 2 P2 June 2021 exam. And this question here is about trigonometry. In this question, you must show all stages of your working. Solutions relying entirely on calculator technology are not acceptable. Okay, so it's solved for theta between 0 and 360 degrees. The equation 3 sine theta plus 30 degrees equals 7 cosine theta plus 30 degrees, giving your answers to one decimal place. All right, so now we have here to solve this equation. We have the terms here in the equation in terms of different sine ratios, trig ratios. You have sine and cosine. So one of the ways that we can try to solve an equation like this is to combine them or make them into one term, either everything in terms of sine or cosine or something else, just one particular ratio, and then it's easy to solve. Now, normally when you see sine and cosine, you would think of sine squared theta plus cosine squared theta equals 1. But in this case, not really, because none of them are squared. If one of them was squared, you could change it in terms of the other one. I could have, if for example it was sine squared theta plus 30, I could then change that into 1 minus cosine squared theta, and then I could continue. I'm just to make it clearer, I'm just gonna call this A here, so it's not confused with that. So that's one identity. Okay, but I don't think that identity is going to help us very much here. However, there's a better identity we could use here. And there's only two identities that we've learned in P2, up to P2. And the other one is a very important one as well. Tan of an angle is equal to the sine of that same angle over the cosine of that same angle. So if we can have something in this form here, then we got sine and cosine, none of them are squared. Sine A, cosine A divided gives you tan A. And we can see here very clearly, if we were to divide both sides of this equation by the cosine of this angle, theta plus 30, you'll end up with 3 times the sine of theta plus 30 degrees, that's the whole thing is the angle, divided by the cosine of theta plus 30 degrees is equal to 7. And we know that the sine of an angle divided by the cosine of the same angle is the tangent of that angle. So this becomes the tangent of the angle theta plus 30 degrees. And I'm going to divide both sides by 3 to get rid of this 3 here. That's equal to 7 over 3. Now that is an equation that I am able to solve. I can now find the inverse tan of both sides. So I have theta plus 30. The inverse tan of this side will cause the tan to go. On this side, it will become the inverse tangent of 7 over 3. And now I can go ahead and use my calculator to find the angles. Okay, but however, we have to be careful about the limits. The limits here are between 0 and 360 degrees. And it's not for this angle, but it's for theta. That's between 0 and 360 degrees. So what we have to do to make sure that we don't lose any solutions, and to make sure that we don't add a solution that shouldn't be there, we should adjust the limits of this so that the middle part here looks like this. So I've got to add 30 degrees to this to make it look the same as that. So you have theta plus 30 degrees. So you have to add 30 to this, so add 30 to all the other parts. So this becomes 30, and this becomes 360 plus 30, which is 390. So we have to find all the angles between 30 and 390, which is satisfied by this, and then we can adjust our answers for theta in the end by subtracting 30 from them. So first of all, let's do theta plus 30 degrees is equal to, so we need our calculator to find the angle. Now we have to make sure that it's in degree mode. It is. If you're not sure, you press shift in this calculator, shift menu, angle unit, and you choose 1 for degrees. Okay, so this has to be in degrees. So we're going to put inverse tan now. So shift here, tan, that's inverse tan of the fraction 7 over 3 equals, and we get an angle which is 66.801, 66.801, and it continues on. Just leave it. So I'm writing it to a higher degree of accuracy than I need in my final answer. So I'll leave it like that for now. Now with the tan curve, there are other solutions which share the same tan ratio, and they're all separated by 180 degrees because of the shape of the tan curve. All right, this is like, has this shape here, has an asymptote at 90 and minus 90, and every 90, every 180 after that, it repeats. Okay, same kind of pattern here like this. Okay, so basically every angle that we find, like 66.8 would be somewhere over here. Okay, this would be the angle 66.8. That would be, 7/3. It repeats again every 180 degrees. So 180 after it and 180 before it, it will repeat as well. The same angle would be repeated. Okay, the same ratio would be repeated. So the ratio of this angle, which is 180 less than 66.8, is the same ratio as this angle, which is the same ratio as this angle, which is 180 more than 66.8. And you can also think about it in terms of the unit circle. All angles have a positive ratio here. This is a positive ratio. The tangent is in these two ratios positive. Okay, so the tangent of this angle, okay, will be the same value as the tangent of this angle. They'll give you the same tan ratio. Okay, so this angle is, of course, 180 more than that angle. This is tan is positive and all are positive. So that's why every 180 degrees. Now, if I take away 180 from 66.8, of course, I'm going to be out of our range. We'll be way before 60. If I add 180 to 66.8, so I've got to add 180 to it. So it's 180 plus 66.801. That's going to give me 246.801. If I add another 180 to this, okay, that's going to be outside of my range because 240 plus 180 is more than 390. Okay, that's going to be like 400 and something. And if I add 180 to this, I'm going to have a 6 here and I have a 12 here. It's going to be 400 and something. So it's outside of the range if I add another 180. And it's outside of the range if I take away 180 from this angle. So these are the two angles that I need. So we can say theta is equal to, now we have to subtract 30 from both of these angles. So this 66.8 minus 30 is 36.801. So 66 minus 30 that's 36.801. And if I take away 30 from 246, that's 216.801, taking away 30 from both of them. And then expressing our answer to one decimal place as asked, you have 36.8 degrees and 216.8 degrees. So those are the two solutions to this answer, to this question, sorry. Okay, so it's 216.8 degrees and 36.8 degrees. And there we have answered part 1 of question number 8. Okay, now we're going to go into part 2. Part 2 says, show that the equation 3 sine cubed x equals 5 sine x minus 7x cosine x can be written in this form here. Okay, so let's deal with this in the following way. First of all, this says equals 0. And so I'm going to bring everything onto one side. So this is 3 sine cubed x. So I'll have minus 5 sine x and plus 7 sine x cosine x equals 0. Okay, now what I'm going to do here is I can see that you've got sine x as a factor of all of these terms, and sine x is a factor of all these terms. That looks like that's 5 sine x. 5 sine x, that's better. Okay, so I'll take sine x as a common factor, and then I'm going to have here 3 sine squared x. I'll have minus 5 plus 7. If you take sine x out, left with cosine x, 7 cosine x equals 0. So let's see what we have to have here. You have the sine x outside, that's fine, but inside you've got cosine squared x and cosine x. So all inside is cosines. Here we got sine squared x. So we're going to use identity that we mentioned in part A that we didn't use, that sine squared x plus cosine squared x equals 1. So we can rearrange this to make sine squared the subject. So we can say sine squared x is 1 minus cosine squared x. So I can replace the sine squared x with 1 minus cosine squared x, and I'll be left with something that has just cosines in it. So I have sine x, that's fine, outside. Then I have 3 times, then I'm going to have, let me just put this in a different shape bracket so that's clearer. 1 minus cosine squared x minus, or let me put plus 7 cosine x, and then minus 5. And that's equal to 0. Okay, just so it has it in the same kind of format. Okay, now we can expand that bracket inside there. So we have sine of x times, and this is 3 minus 3 cosine squared x plus 7 cosine x minus 5 equals 0. And then I can now combine the like terms, the 3 and the minus 5. So I have sine x, and then I'm going to have minus 3 cosine squared x plus 7 cosine x, and 3 minus 5 is negative 2. So I have minus 2. That's plus 7 cosine x, and minus 2 equals 0. So we put it in the form that's needed. You've got sine x, and you have something times cosine squared x, which in this case is minus 3, then something times cosine x, which in this case is plus 7, and then you've got plus c, which is minus 2. It's possible actually for you to multiply both sides of the equation by minus 1. And that's possible. So the answer, like for example, if we express everything on the other side of the equation, you would have got something that looks slightly different. You would have got something that looks like sine x, and this would have been 3 cosine squared x minus 7 cosine x plus 2 equals 0. That's also possible. So both of these are correct. Okay, because if I multiply both sides by minus 1, this will become, this will become positive, and this will become negative. This will become, because they'll change signs. So both of these are correct. So this or that are both correct answers for this question, part 2A. Okay, so that's number 8, part 2A done. Now we're going to do 8, part 2, part B. So it says, hence solve for this, range the equation. Okay, so we've got the same equation exactly. So what I'm going to do is I'm going to go and bring back our result again. Okay, so we showed how this becomes this. All right, I've used the one with the positive x squared in front of it because it makes it easier, the cosine x squared, because it makes it a bit easier. So what we can do here is we can make this into a quadratic. This is not quadratic. Yeah, well, this is a quadratic, but we can say that if this factor times this factor is 0, then we can say either sine x equals 0 or all of this equals 0, which is 3 cosine squared x minus 7 cosine x plus 2 equals 0. So we have these two parts of it, and this will of course probably factorize, and we will end up with another two kind of equations, which we can then solve to find all the values that we need. For sine x equals 0, now let's see how they want it. They said, okay, between minus pi over 2 and plus pi over 2, so that's an indication they want us to use radians. So let me just straight away make sure that we're ready. So change this into radian mode, which is press 2 here. Now it's ready in case I forget. So we know that we have to do it in terms of radians. Okay, so now this angle x is the same as this. There's no problem with that. There's nothing to add or subtract. So we've got to find all the places where the sine of x equals 0 between minus pi over 2 and pi over 2. Now sine x equals 0 at 0. So when x equals 0. And then that's the only place, if you think about the sine curve, it goes like this. Okay, and it goes like this. That's minus pi, and that's plus pi. We want between pi over 2, minus pi over 2, and pi over 2. It's only 0 at 0 degrees. So that's the solution for this part. That part's done. Okay, now we got to solve this part. Now, what some people like to do is they say let cosine x equals, they call it a letter, for example, we can call it b. All right, so we can say this is 3b squared. Remember, cosine squared x is the same thing as cosine x all squared. It means the same thing. So 3b squared minus 7 times b plus 2 equals 0. It's just to make it more familiar looking as a quadratic. Then we can factorize this. There's different ways of factorizing it. I'll show you two ways of factorizing it. The one that you're probably most familiar with, which is splitting the middle term. And then something very similar to this, but just in a visual way. So here we're going to find two numbers that multiply together and give you 6. This is called the AC method, because you multiply A by C to find the numbers that this splits up into. So two numbers, they multiply to give you plus 6, and their sum is going to be minus 7. All right, so those two numbers must have the same sign, all right, because they give you positive. They're both negative, so it must be minus 6 and minus 1. So so now we found the pair of values, minus 6 and minus 1. We can split this minus 7b into two parts. Okay, one of them is going to be minus 6b, and the other one is minus 1b. So I'll write this as 3b squared minus 6b minus 1b plus 2. So we take out the common factor from these two terms separately. So you have 3b 3b times b minus 2. Then you're going to write the minus, and there's nothing common, so you write 1. And minus b times b, minus 1 times b is minus b, and minus 1 times minus 2 is plus 2. So there's a minus 2 has to be here. Because when you multiply them, you get that. Okay, both of these should say equal 0. Now I can take out the common factor from these two terms, which is b minus 2. And this is 3b minus 1. And then I write that equals 0. Now I can find the solutions. If b minus 2 is 0, then b is equal to 2. And if 3b minus 1 is equal to 0, that means b is equal to 1/3. So those are the two solutions for b. I'm going to just continue on the question later on. Just showing you the other method that I like to use. I like to use this kind of visual factorizing method using this grid. So I'm going to start off with 3b squared on the top left and plus 2 in the bottom right. Again, I do the same process, two numbers that multiply to give you the same as these two. So these two numbers have the same product of those two, which is 6b squared. And the sum of those two numbers must be the same as this minus 7. So, of course, it's the same two numbers. Okay, minus 7b, so it must be minus 6 and minus 1. So minus 6b and minus 1b. And I can write them anywhere in these two that I want to. So, for example, if I put minus 6b here and minus b here, that will be fine. Now, I can take out the common factor from the rows and the columns of any one I choose to, and we'll be fine. So, for example, if I look at these two terms and I write out here the common factor of 3b squared and b, the highest common factor is b. Then I can say, all right, I know that the area of this kind of rectangle is b times something. B times something gives me 3b squared, well, that must be 3b. And b times this length here gives me minus b, well, that must be minus 1. And 3b times this gives me minus 6b, that must be minus 2. 3b times minus 2 is minus 6b. And these are my two factors. So I end up with, I'll just write it down here, 3b minus 1 and b minus 2 equals 0. And then I proceed in the same way, getting b equals 2 and b equals 1/3. Okay, now, those are our two solutions. Okay, but that's for cosine. That's for cosine x. So remember we said let b equals cosine x. So now we can say that cosine x is equal to 2 or cosine x is equal to 1/3. Now here there's no solutions for this because cosine x never reaches 2. If I press inverse cosine of 2, it will give me math error. Why? Because the cosine curve looks something like this. And the highest it ever gets to is 1, and the low it ever gets to -1. It never goes above 1, it never goes below -1. So that particular branch of it has no solutions. But this one, you're going to press the inverse cosine of 1/3, and that will give us our values. Okay, but remember we have to choose the values between 0, minus pi over 2, and pi over 2. Remember, that's our limits was minus pi over 2 and pi over 2. Okay, so I'm going to find inverse cosine of 1/3. So it's in radian mode already. Inverse cosine of 1/3. And that gives me 1.2309. So x equals 1.2309, ... continues on like that. That's the number of radians. Now, the cosine curve between minus pi over 2 and pi over 2, it looks like this. Right, so between these values, if there's a value here, it's mirrored exactly over here. It has a negative twin, you could say. Okay, so there's going to be another value of x, which is negative 1.2309. And this is less than pi. Its value is less than pi over 2. If you look at pi over 2, if you do, if we double this, for example, okay, let's do pi over 2. So 3 point, in fact, I can just take it from here. Pi divided by 2 gives us a value which is 1.57, and this is less than 1.57, so this is okay. And this is, within or greater than minus 1.57, so this is okay. So both of these are within our range. Okay, so the answers are as follows okay, they didn't say how to express the answer, but if it's in radians like this, it's best to put 3SF. If it's in degrees, it's normally 1 plus 1 decimal place. So we have the solutions are originally from the beginning, we had x equals 0, okay? And we also have minus 1.231. I'll write it to 3SF. Okay, so we have the 0, and then we have 1.231. So these are all the solutions in radians to this particular equation, where we used part question 2, part A. Okay, we used our result from that in order to solve it. So those are the answers for part B, and I think that was it. That was question 8, yes. So question 8 is now complete in this P2 paper. Thank you for watching. Other questions which are to do with, oh, by the way, for the cosine curve, just a little point, they repeat every 360 degrees. Okay, so for example, there would be another angle here, which would be 360 away from here. But there's also that there's two main angles. The first main angle is what the calculator gives you, which was this. The second main angle would be 360 minus this angle. So 360 or 2 pi minus this angle would be too big. 2 pi minus this angle would be more than pi over 2. Okay, so we can't choose that one. But then we also have 360 or 2 pi less than both those angles. So let me just show you how to do this in this other way. So this is the angle that I got in my calculator. All right, so the kind of like the standard way of doing this is as follows. Let me just go back. Yeah, so that was the answer that we got in the calculator, right? So if I do, for example, if I do 2 pi minus this angle, so I'm going to have, okay, so I'll have 2 pi minus this angle. That gives me 5.05. I'll write it down. So 5.0522. 5.0522. Now that's too big, right? But that's the other main angle. There's two main angles with cosine. Okay, so you get your angle. We got the angle here, and we got another angle over there somewhere. But we're only stopping at pi over 2. We're stopping here. So this angle is out of our range. But there's another angle which is 360 less than this angle, which would be over here, which is within our range, because that's minus pi over 2 here. So we can find the other angle that we need, which is this angle minus, okay, this angle, take away 2 pi. And of course, that's going to give you, okay, take away 2 pi, it's going to give you minus 1.231. So you're going to have the other angle is minus 1.2309. That's the other angle, which is this angle take away 2 pi, and it gives you this. Okay, so those are the two angles within our range. All the other angles are separated from these by 360. So they're all out, or 2 pi in radians. So they're all out of our range except for these two. And then we have to include the 0 from the original equation where we had sine x equals 0. Okay, this one here, sine x equals 0, or this equals 0. And then we get all the three solutions to the problem. So that's just another way of thinking about it. For this particular question, as it's only between minus pi over 2 and pi over 2, you get an angle over here that's going to have a negative twin. So that's also within the range. So you can just take the answer and just put a minus in front of it, and we got the answers that we need. So that's how you can deal with trig equations. Thank you for watching. Other questions from P2 trig can be found in the playlist over here. Other questions from this particular paper of June 2021, P2, can be found in this section or this playlist that should appear over here. You can subscribe to my channel by clicking on the link, and in the description you can watch other videos that you might want to see from the papers I've answered: P2, P1, P3, P4, S1, M1, also some IG papers. Thank you for watching, and see you soon.